Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science. I'm president of Transpower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I also work as a theoretical economist and as an operations researcher. My very first commercial software package is called Optimal Manager, published in 1982, as you can see here on the sign-on screen. This is an operations research management science software package of 47 program units with many sub-program units. We've already covered module 1 of the 4 modules. We're now in module 2. I'm going to press enter. You can see the 4 modules here. We're an optimal product manufacturer now, so I'm going to hit II. And we're going to go with Program Unit 3 today, Optimal Allocation of Material to Products. So I put in 3, enter. Would you like to see the program unit description? Yes. You can get a manual with this, but it's not really necessary because all the descriptions are in the program themselves. Originally, the whole package with a manual cost $495. We've drastically reduced the price down to $95. Probably stay there for a long time, and you can still get the manual for $95, but it's really not usually necessary. All right, so let's read the description here. Optimal allocation of material to products. This program unit solves 3 problems in the optimal allocation of material to products: the feed problem, the mix problem, and the trim problem. A. Feed problem. Inputs to this subprogram unit consist of the number of feeds or foods, the number of compounds, for example, vitamins, minerals, the amount of each compound in each feed, the cost per unit of each feed, and the required supply of each compound in the diet. The subprogram unit outputs consist of the amount of each feed to purchase so as to minimize cost while satisfying all requirements. Okay, subprogram unit B is the mix problem. Inputs to this subprogram unit consist of the number of ingredients, the number of compounds, the amount of each compound in each ingredient, the supply of each ingredient, the required amount of each compound in the final mix, and the amount of the final mix. The subprogram unit outputs consist of the amount of each ingredient to put in the final mix so as to minimize cost while meeting all requirements. And then the third subprogram unit is the trim problem. Inputs to this subprogram unit consist of the number of possible cutting patterns, the number of different products, the quantity of each product that can be made from each cutting pattern, and the required quantity of each product. The subprogram unit outputs consist of the quantity of each pattern to use so as to minimize consumption of the raw material. Linear programming is used for all 3 problems. All the mathematics are included in each program unit. It's not like a spreadsheet where you have to put in your own equations. Everything is built in entirely. So it's extremely easy to use. Now we're going to hit C to continue. And we'll go through each of these subprogram units in order. So let's go to 1, feed problem. And we'll take the sample file 1. I'll hit E to edit. And all I have to do is just read the bottom of the screen to tell you what the field is. So this is the report title, name, company, date. So this is first run in 1982. This is beef, 5 feeds, 4 compounds. How many compounds, vitamins, minerals, and feeds? Okay. We'll accept that. Now we'll do E to edit here. Now again, I'm running this. This is a DOS program written in 1982, but it will run under any form of Windows, 32-bit or 64-bit. I'm running 64-bit Windows here. Unfortunately, DOSBox does not have a config.sys file, so I can't set device equal ANSI IBM.sys. So it's not quite lined up, but you can think of this as like a 3D effect. Anyway, the output is all lined up, so it doesn't really matter. So the prompt says, what is the minimum size of compound 1 required in the diet? It's 10. and that can be whatever units, 10 grams, 10 pounds, whatever it is. And then on the side, compound 2, 20, compound 3, 15, compound 4, 5. Hit accept. Edit this screen. What is the cost per unit of feed 1? Let's say it's $5.25. Cost per unit of feed 2, 7.5, etc. for all the other ones. Accept that. Now we edit this. How many units of compound 1 are in each unit of feed 1? So compound 1 in feed 1, compound 1 in feed 2, compound 1 in feed 3, compound 1 in feed 4, and compound 1 in feed 5. And in the second row, how many units of compound 2 are in each unit of feed 1, feed 2, 3, 4, 5, and so on for the other compounds. So just read the bottom of the screen if you're uncertain. Hit A to accept. At this point, you can save the data and then compute. Go back to screen 1 or compute only. We'll just hit C. Computes immediately. Go to screen only. Screen link. Prints all the output consists of all the input as well. Everything is lined up here on the output, so no problem with that using DOSBox. So amount of each compound in each feed is given in this table, and then the required minimum supply in the diet. You can see the compounds there. And then we have the optimal quantity of each feed. In this case, wow, it's going to be just feed 3 and 5. Total cost of the feed 17. Okay, so that was easy. So now let's exit back to the module menu. Go back into II, go back into 3, and we'll skip the description this time. We'll now go to the mix problem 2, and we'll load a sample file 3, E to edit, lowest cost mix, your name would go there, that's my name, company, date, chemical mix. We have 3 ingredients, 3 compounds, and 400 is the final mix. You can use, just be consistent in your units, please. Accept, edit this. Required amount of compound 1 in the final mix 100, compound 2 in the final mix 50, compound 3 in the final mix 25. Accept, edit this. Supply of ingredient 1, supply of ingredient 2, and the cost, supply of ingredient 3, and the cost of ingredient 3. Accept, edit this. How many units of compound 1 are in each unit of ingredient 1? Compound 1 each unit of ingredient 2. Compound 1 each unit of ingredient 3. And the same for compound 2 and then compound 3. Accept. Compute only. Computes immediately. Screen. So here's the chemical mix. Here's the supply of each ingredient, cost per unit. Required minimum supply in the final mix for each compound. So amount of each compound in each ingredient that's put in, required minimum supply in the mix is 400. So here we have ingredient 1, optimal quantity is 200, cost is 250. Ingredient 2, optimal quantity is 109.47 with the 189.47 cost. I'm sorry, 189.47 quantity, and cost is the same because it's 1. Ingredient 3, 10.53, 18.42 for the cost. And that gives you the total cost of ingredients, 457.09, which is that addition there. 457.889. I get zeros and eights are a little bit hard to read. All right. Okay, so that's that. We got one more unit to go. Exit. We'll go back. I3. We'll skip the program unit description. Now we'll go to the trim problem. So yes, we want to use a sample file. 5. Edit. Optimal trimming. It's like pressed plastic. We have 5 cutting patterns. We have 3 products we want to make. Accept that. Edit. Required quantity of product 1 is 900. Product 2 is 700. Product 3 is 600. Accept. I'm going to edit this. Again, it's not lined up because there's no config.sys in DOSBox, but it's like a 3D effect, and you just read the bottom of the screen. So, how many units of product 1 can be made from pattern 1? From pattern 2, 3, 4, and 5. How many units of product 2 can be made from pattern 1, and so on. And then how many units of product 3 can be made from pattern 1. Okay. Accept. Compute only. Super quick. Screen length. Quantity of each product in each pattern. So that's input in the product, and the required minimum quantity is there. So here's the pattern and the optimal quantity. So it's 225 for pattern 1, 350 for pattern 2, 300 for pattern 5. We're not using patterns 3 and 4. Total quantity of patterns is 875. And that's it. So this is an example of applied linear programming. So I'm going to exit back to the module menu here. So again, we've reduced the price all the way down to $95. Everybody can afford this. Just one use of this program, of any of the programs in here, would probably save you that amount of money in your business. So it's a super bargain. All I have to do now is to send a Dropbox link if you make an order, instead of shipping, putting the printed manual and the diskettes into a box, or the CD in a box, and then going to the post office. Now it's just a matter of giving you a Dropbox link, and that's it. You're ready to go. So it's real simple these days. Optimal Manager is still the only software package out there to have 47 program units with many sub-program units. Like today's program unit had 3 sub-program units. So it's extremely comprehensive, covers all the basic applications of operations research and management science. So if you stick with me through all 47 program units, you'll have a good basic understanding of operations research and management science. Okay, that'll do it for today. Thanks for your attention, and bye for now.